This is a complicated circuit with resistors and capacitors. We're going to look at what's called a steady state condition. What that means is we're going to turn the circuit on, and the current's going to indeed begin to flow. It'll reach this branch here. This branch is parallel to this branch here. And we will charge this capacitor through time. And once this capacitor is totally charged, the current on this branch is going to go to 0. The current will continue to flow around this way. Now again, when this branch goes to 0, there will be no voltage on this capacitor here. Remember, our equation is V equals IR. If the current on the resistor is 0, then there's no voltage on the resistor. That means all of the voltage in this branch here is going to be on this capacitor here. So how do we calculate that voltage and charge? That's kind of what we're interested in here today. But we realize that this branch here is still going to be going, and it indeed is parallel to this branch here. So we want to calculate whatever voltage on this resistor here, since it's parallel to this capacitor, must also equal the voltage on this capacitor here. So using Ohm's law, we can figure out the current going through here, and we can figure the voltage on this one. And that must be the voltage on this one here. Okay, but I'm going to use a voltage divider rule instead. A millivolts on this has to be a fraction of the total resistance here. So this is how we do it. We can take the volts total, and then we can multiply that. Okay, and multiplying that, we can say that, well, the volts total, first of all, is 18. We need to record that. So I'm going to take that volts total. I'm going to multiply that by R3 divided by R2 plus R3. And that will actually give me the voltage on the resistor R3. Because what we're saying is what fraction of the total resistance is R3, and multiply that by the total voltage. So let's do that right now. So we say 18 multiplied by 91 over 43 plus 91. And that gives me 12.2 volts. And notice I'm not putting the kilos in there because they're all kilos and they would cross off. So now I know the voltage on this capacitor is equal to 12.2 volts because I know the voltage on the 91 ohm or kilo ohm resistor is 12.2 volts. So I just use a voltage divider rule to figure that out. Now what about the charge on the capacitor? Well, I can just do charge is equal to C times V. So I've got my charge is equal to my C, or my capacitance, is 100 microfarads. And I'll multiply that by 12.2 volts. Okay, and that gives me a charge of 1.22 times 10 to the third microcoulombs. And that's how you analyze a circuit with capacitors and resistors together.